So for those of you that missed the lab, here you go. Pre-lab and lab together all at the same time. In general, whenever we're talking about LeChat Lab, which if you have no idea what I'm talking about when I say LeChat Lab, you might want to go to your book, look it up in the index, read a little bit about it just to kind of familiarize yourself with some of the vocabulary before I start talking about this. But when you add something to a closed system, the reaction is going to shift away from what was added, or if you remove something, it's going to shift towards whatever it was that was removed. So there's a couple of different ways that you can, add or remove things. First thing is concentration. So if chemicals are added, the reaction shifts away from that chemical. If it's removed, the reaction will shift towards that chemical. And look for common ions, and that's the examples that are going to come out. And what I mean by common ions, like let's say you're doing the ionization of potassium nitrate. And if you wanted to increase the potassium concentration, you could add maybe potassium chloride. And that would be a source of a potassium ion. So look for commonalities like that. All right, so concentration example, you got sodium chloride, the ionization of sodium chloride, basically taking sodium chloride salt and dissolving it in water, which as soon as sodium chloride hits water, it turns into sodium ions and chlorine ions. And so if you add, say, a chlorine ion, in maybe like the form of hydrochloric acid, because hydrochloric acid, as soon as it hits the water, notice I draw a unidirectional arrow here, it separates into hydrogen ions and chlorine ions. Well, there is your common ion. So if you add hydrochloric acid to a salt solution, then what it's going to do is increase the amount of chlorine ions, which things shift away from what is added. So then that's going to cause more of this solid, more of this solid salt to form, and the amount of sodium is actually going to go down. So it looks like that. Adding chlorine in the form of HCl means you're going to shift left, decreasing the ions, increasing the sodium chloride. All right, another concentration example. If you have BTB, stands for bromethymol blue. It is an acid-base indicator that indicates around neutral pHs. In acidic solutions, it is, acidic is yellow, and basic is where it gets its name, bromethymol blue. And so in this case, real easy source of hydrogen ions. You saw it on the last slide. If you take HCl, it ionizes into hydrogen ions and chlorine ions. Now this time it's our hydrogen ion that's the common ion, not the chlorine. So the chlorine doesn't really do anything. Later you'll learn it's what we call a spectator ion. And so if you add acid, that increases the amount of hydrogen. You shift away from what was added towards this BTBH, where the bromethymol blue is actually bonded to the hydrogen, and it's this compound that's yellow. And then if you remove the hydrogens, the easiest way to remove a hydrogen is by adding a base, say sodium hydroxide, which ionizes into sodium and hydroxide. This hydroxide here is going to seek out these little hydrogens and form water. And so it basically takes these hydrogens and yanks them out of solution, thus decreasing the hydrogens. And in this particular case, let me erase. Well, I don't want to erase the pen. If we add a base, then we're going to decrease the hydrogen. I know, I'll switch colors. If we add sodium hydroxide, we're going to decrease the amount of hydrogen, which means you're going to shift towards what you remove. And what you guys will discover is that this BTB minus ion is blue. So that looks like that. Then the last reaction that we're going to do, if I can get it to come up, is the iron ion. This is the thiocyanate ion. And when these two guys come together, they form the iron thiocyanate complex. And no, this is not balanced, but don't worry about that. This is a very complicated reaction, but this is just the part that you need to see. Go back to white here. 3 different things that we're going to do to this. The first thing that we're going to do is we're going to add iron. And we're going to add iron in the form of iron nitrate. This will ionize into the iron ion in the nitrate, and that's going to increase the concentration of this. So increase that means that we are going to shift away from what was added, and what you will actually see is this iron thiocyanate complex is a really deep red, very deep dark red. Then what we're going to do is attempt to shift it back the other way. Kind of hard to add this compound, it's not really going to do anything, but if we removed one of these two, then we could shift it back towards the left, and it's actually quite easy to pull iron ions out of solution by using anything with a phosphate ion, because this little phosphate ion, just like the hydroxides in the BTB reaction seek out the hydrogens, this phosphate ion is going to seek out these irons. It's going to form the insoluble compound FePO4, which is going to precipitate out of our reaction. Remember, that's the symbol for precipitate, which in essence removes iron ions from solution. So that means this will go down, cause it to shift towards what was removed, and what you see over on this side, these are colorless, so we'll just put clear, and so it'll actually turn back to clear. And then we can shift it yet again by, we could add more iron if we wanted to, that would work, but just trying something different. If we added some of this, and we can really easily add the thiocyanate ion by adding potassium. Oh, sorry, can't spell. Thiocyanate. And that's going to increase this, which means we're going to shift away from what was added, and it'll turn right back to this deep dark red. And that looks like that. If you have any questions, feel free, come on in, ask. I'll be here. All right, I'm done.